Hi there, how's it going? My name is Ricky, and this is Not a Number. Now, today we're going to be looking into something that I've been learning a lot about lately, and that is pixel sorting. If you're not familiar with pixel sorting, it is essentially just using a sorting algorithm to rearrange the pixels of an image in a certain order. For example, today we're going to be sorting the pixels of an image by their brightness. Now we're going to be using the bubble sort method for this video. If you know anything at all about sorting algorithms, you probably know that the bubble sort method is about the least efficient method that you can use to sort, but it's also a good base case to learn before moving on to more advanced sorting algorithms. Now I'll explain more about how bubble sort works as we get going, but in order to do any actual sorting, we need some code to work with. So I'm going to be just using an HTML5 Canvas element to house our image and using JavaScript to do the sorting. Obviously, you can do this in a variety of languages, but this is what I'm most familiar with, most comfortable with, so this is what we're going to use for right now. Now, I just need a very simple HTML file here. So I'm going to use the HTML5 doc type, and then open our HTML tag here. I can type. And then inside of our HTML tag, we're going to have our head. And then inside of our head, we just need a title. And this title, I'm going to call it Pixel Sorting Bubble Sort. And then I'm also going to load in our JavaScript file. So we're going to have a script tag. And our source is going to be this bubble sort.js file. That's all we need in the head, and then in the body we're going to need a canvas tag to hold our image. So just add a canvas element, and we're going to give it an ID of just canvas so we can reference it in our JavaScript, and that is all we needed in our HTML file. Now we can load up this or refresh this page in our browser, and we can see that we have a tag, and then if we look at the elements in our HTML, we can see that we have the canvas element. So let's switch back to our brackets here and start working on our JavaScript file here. So the first thing that we need to do is we need to make an image load, right? So we can sort it. So we're going to do this when the window loads. So we're just going to add an onload function. Make sure we add our trailing semicolon there. And then I'm going to create an image. And then add the source as the Detroit.jpg file that we have in our folder here. Now, in order to add that to the canvas element, we need to reference our canvas element. And so I'm going to create a new variable and assign that to document.getElementById canvas, so that references our canvas HTML DOM element. And then I'm going to set the canvas width and height to the same width and height as our image. So our image is 150 pixels wide, and then the height is going to be 103 pixels. And then in order to actually add the image to the canvas element, we need to get the what we call the context of the HTML5 canvas element. So we'll create a variable called ctx for context, and we're going to set that equal to the canvas.getContext, and we're going to get the 2D context. So what's going to happen now is when this code runs, it's going to create this image file, it's going to assign the source, and then even though we haven't actually added this image to the DOM yet, it is going to load that image, and we can execute code when that image loads. So we can create an image.onload function, and again, add our trailing semicolon, and when that image loads into memory, we want to actually draw that image to the canvas. So we're going to take our canvas context, and we're going to tell it to draw the image, and we're drawing the. It takes 3 parameters: the actual image we want it to draw, and the x and y coordinates inside the canvas element where we want it to draw. So we want it to draw the image, and we want it to draw it at 0, 0. And that is it. So now if we go back to our browser and we refresh the page, nothing happens. What did we do? We have an unexpected token on line 12. That's because I misspelled the word function. And now draw image is null because I put 2x instead of 2d. Always check your typing, people. Always check your typing. Alright, so now we have an image, and this is actually zoomed in. That's why it looks so big. But it will actually be helpful to have this zoomed in later, so we can actually see what's going on. So now we have an image that we can actually sort. Now the way that the bubble sort algorithm works, it is that it essentially takes the first 2 items in your array. So in our case, the first 2 pixels of this image, and it sorts them. So if we're sorting by brightest from the brightest pixel to the darkest pixel, it looks at those first 2 pixels and says, is the first one brighter than the second pixel? And if not, swap their spots. And then it moves on to the next set of pixels, so pixels 2 and 3. And it says, is pixel 2 brighter than pixel 3? If not, swap them. And so on and so forth until it gets to the last 2 pixels, and it says, is the second to last pixel brighter than the last pixel? If not, swap them. By the end of that process, we will have the darkest pixel at the last spot in the image. And then we repeat that whole process over and over again for as many pixels as we have in the image. And by the time it's repeated all those processes, we will have an image that is sorted from brightest pixel to darkest pixel. So now let's go back to our code and see how we start manipulating the pixels of this image. Now in order to actually be able to manipulate the pixels of this image, we need a variable that holds them. So we're going to create a variable in the Windows scope and global scope called image data. And we're going to set this to the context.getImageData. Now this getImageData function takes 4 parameters. It takes the x and y coordinates where you want to start gathering data, and then the x and y coordinates where you want to end gathering data. So we want to start at the top left pixel, which is pixel 0, 0. And we want to go to the bottom right pixel, and that's going to be at the canvas width and the canvas height. If I can type. So now this image data object holds all of our data that we can manipulate. And it's worth going and looking and exploring that in the JavaScript console a little bit. So if I refresh this page, now we should be able to have this image data object. And you can see that the width is 150, the height is 103. And you can see that it contains a sub-object, which is actually an array called data. And you can see that this data array is 61,800 items long, which is, you might think, is interesting if you're not familiar with how the image data object works, and maybe if you're not familiar with how arrays work in JavaScript. So JavaScript does not support natively what we call multi-dimensional arrays. You might think that you would have a 2-dimensional array that would contain all the rows and all the columns in the image, but JavaScript doesn't support that natively. And so what this image data object contains is actually one long array with all of the pixels. And so you say, well, Ricky, if you do your math, 150 times 103 is 15,450. So why is the array not 15,450 items long? Well, what it actually does is it stores the red, green, blue, and alpha value of every single pixel as a separate image value. So if we look at this image data um, value at position 0 is 48, that is the red value of the first pixel. If we look at 1, we get a value of 2, which is the green value of the first pixel. And if we look at 2, we see 57, which is the blue value of the first pixel. And if we look at 3, we see 255, which is the alpha value of the first pixel. And then if we look at the element in position 4, we see 48, and this is now starting the red value of the second pixel in the image. So you can see there's actually 4 items in the array for every single pixel, which is why you see 15,450 times 4 elements in the array, which is 61,800. So we need to know this when we start manipulating the pixels. So if we go back to our code now, we know we have the information that we need to get started. We know how the image data object works, and we also know how the bubble sort method works. So we know that each time that we sort a single pixel, we're going to have to iterate over an array a certain amount of times. And we also know that we're going to have to do that iteration for as many pixels as we have in order to sort every single pixel. So we're going to need a couple for arrays. So the first one that we're going to do is for the number of total iterations that we need to do. We know that's going to be for the number of pixels that we have. So I'm going to declare a variable n starting at 0. And we're going to do this for n is less than image data dot length. And then usually when you do a for loop, you increment with something like that, a plus plus to increment by 1. But we need to keep in mind that every pixel is represented by 4 data elements in the array, 4 elements of the array. So we need to actually increment this by 4 each time. We can do this with an n plus equals 4. That will increment by 4 each time this loop runs. Now this is going to be a nested for loop because each time that we're sorting one pixel, we have to do comparisons for every single pixel in that array. So we're going to basically loop through the entire array, and then we're going to do that iteration for as many pixels as we have. And you'll be able to see this a little easier. It becomes more apparent when we actually see this in action. So what we're going to do is do another loop, and we're going to do var I equals 0. I'm going to do this for I less than image data. And I'm going to explain this, why we're doing this in just a minute. But what we're going to do is image data.length, that data.length minus n minus 4. And then again, we're going to increment this I by 4 every single time. So let me start with, why are we going to image data.data.length minus 4, which is essentially minus 1 pixel? That's because every time that we run this, we're comparing what we're going to call the current pixel to the next pixel after it. So if we ran this on the very last pixel in the image, there would be no pixel after it to compare it to. So we really need to compare it to the number of pixels we have minus 1. And since each pixel is represented by 4 elements in the array, we really need to go to the length minus 4. And then we'll explain the minus in later if you're not picking up on that. So what we need to do Every time we iterate through this array, we need to compare the current pixel to the next pixel. We need to compare the current pixel's brightness to the next pixel's brightness. And in order to know the brightness, what we're going to do is average the red, green, and blue values. So we need the red, green, and blue values for the current pixel and the next pixel. So what we're going to do is create variables for all this. So we're going to create a variable called current red for the current red value, and we're going to set this to image data dot data I, which is the current, which is the first value of the array. And then we will create, oops, sorry, this is misspelled. Do this for the red, green, and blue values. So green, if I can type. I've probably said that about 10 times in this video so far. Now the blue is going to be, the green value is going to be the one that follows the red value. So we'll add a +1. And then 2 values after that is going to be the blue. And then we can then do the brightness. And this is going to be the red value plus the green value plus the blue value. We're going to divide that by 3. Now we need all of that for the following pixel. So I'm just going to replace cur with next on all these. Now to get the values for the pixel following the first one, remember if we look at pixels 1 and 2, for example, image data 0 is going to be the red, 1 is going to be the green, 2 is going to be the blue, 3 is going to be the alpha, which we don't care about the alpha, but then the start of the next pixel is 4, so we actually need to go +4 here, +5, and then +6. Now all we have to do is check the brightnesses and see if the pixels need to be swapped. So we do that by saying if the current brightness is less than the next brightness, then we're going to swap all the data. So we're going to start with image data dot data 0, and we're going to set that to the value of next red. And then we're going to do that a total of 6 times. But then we're going, oh, this should actually be I, sorry, not 0. So then we're going to go I plus 1, I plus 2, and then again, remember we're going to the next pixel, so we skip 3 because that's the alpha value, so we're going to go I plus 4, I plus 5, and then I plus 6, and we're going to set this to, this is going to be the green value, this is going to be the blue value, and then we're going to go back up to the original red, original green, and original blue. Oops. And that will swap these pixels. So what's going to happen is we're going to start at 0, and it's going to compare 0 and 1 and swap them if they need to. And then this array, this loop is going to go back again, but we're incrementing by essentially 1 pixels, and it's going to go compare pixel 2 to 3, swap if needed, loop around again, go to pixel 3 and 4, swap if needed, so on and so forth until it gets to the second to last and last pixel. And then that loop is going to be done, and then it's going to, this loop is going to iterate, and it's going to start the process over again with I at 0, but then this is what's important, and this was the n I was talking about earlier. It's going to loop, now n is going to be equal to 4, so it's going to be looping through the end of the array, minus 1 pixel, minus another pixel. So it's going to compare all but the last 2 pixels, all but the last pixel. The very last pixel is not going to get compared at all, which is okay because we know it's already sorted. So it's essentially every time it's looping, we're comparing 1 fewer pixels because we know that that pixel has already been sorted. It's already in its final place. There's no need to compare it again. So now the last thing that we need to do is actually tell it after we're done sorting to actually update the canvas image context. We do that by calling ctx.putImageData, and this takes the actual image data that we want to update it with, and then the x and y coordinates where we want to update. And then if I did everything right, I should be able to go back, refresh the page, and after a few seconds we'll see a sorted image. And I did actually, through a little bit of troubleshooting, realize that I needed to update this. I had this as an equals plus instead of a plus equals. But now that I saved that, go back, refresh our page, and then after a few seconds you can see we have a sorted image. It doesn't look super amazing, but it is sorted as the brightest pixel to the darkest pixel. Now, half the fun of pixel sorting to begin with is watching your watching your image being sorted in real time. Now, the reason that we're not seeing it happen in real time is because of the synchronous nature of for loops in JavaScript, meaning that the entire for loop runs before the browser DOM is updated. However, we can update this code to make it asynchronous so we can watch each pixel being sorted individually. We can do that by moving this code, the code that actually does the sorting, into its own function and making it an asynchronous function and making it perform one step at a time. And I'll show you how we can do that. So let's create a new function called bubble sort. And let's paste in this code. We can fix the indentation real quick. And then we're going to change these for loops into if statements, and then we're going to move these counters out into their own variables outside of that function. I'll show you why in just a minute. So we're going to say var n equals 0, var I is equal to 0. And essentially, what we're going to do when we change these into if statements is we're going to have this function perform one check at a time, and then we'll just repeatedly call this function over and over again, render after each function update so that we can see the pixels being updated in real time. So we moved our counters out, but since we changed these to if statements, we need to kind of manually add in the incrementation. So every time this if statement runs, we want it to increment I by 4, like we did in the for loop. And then once this condition is met, once I is no longer less than, we want to add in an else here where we reset I and then we increment n. And this basically takes care of the same thing that our for loop does. Now, every time this function runs, we want to, again, this basically renders the image, but then we want to call this function again. And in order to make this asynchronous, we use a fancy trick called set timeout. We tell it to call this function again, and we don't necessarily want any time to pass, so we just have it call immediately. We put 0 in there, which makes it just immediately call the function as soon as it gets added to the call stack. And again, obviously, we do need to kick off this function call, so we can just add bubble sort up here. And again, crossing fingers, if I did everything right here, we should now see that what happens is when that image file again first loads, we set up the context, and then we call bubble sort to begin with. These counter variables are already initialized because actually, again, what is happening, the way JavaScript works, is these variables are actually getting defined up at the top no matter what. So these variables are already defined. And again, I'm not an expert on exactly how JavaScript rendering or parsing engines will work, but I do know that much. So then when this bubble sort function gets called, again, it's doing everything that we expect it to. So the first time n is equal to 0, I equals 0. So it's comparing first pixel to second pixel. It swaps them if needed. It increments I. This block does not run yet because n is still less than image data dot, or sorry, I is still less than image data dot length minus n minus 4. So then it draws the updated pixel and then it calls it again. So this is essentially doing exactly the same thing as we did before with the for loops. We just made it asynchronous. So now if I swap over to the browser and I refresh, we see our unsorted image here. And it'll take a few minutes for you to be able to see it, assuming everything worked right, because all these pixels are very close to the same color. But we should, after a minute here, see that you should be able to see a pixel kind of sliding across the image. Let me just make sure that nothing broke here in the console. I did. Oh, this is very good here. Context is not, CTX is not defined. Let me scroll back up here, and I did that because I made CTX a variable that is local in scope to this function. I need to make this a window scope variable. And now it will be scoped properly to be able to be referenced down here when we go to try and draw it. So let's refresh the page again. No console errors. And now let's see if we can see a pixel being sorted. It's much, much slower this way because it's having to spend a lot of time redrawing the image and adding functions, calls to the call stack over and over again. But you can see, hopefully you can see this in your video, that you can see a pixel scrolling across the screen, and this is one single pixel getting sorted. So we'll give it another minute here to work its way down to the bottom, but what you're going to see is that a very dark pixel will end up down in the bottom corner here, and then it will start over again from the top. And it's going to do this over and over again until every single pixel in the image is sorted. So I'm going to pause the recording here, and we'll come back in a few minutes and see it a little further along in the process. Alright, it's been about 5 minutes, and as you can see, it sorted a couple more pixels. It's not moving terribly fast. I'm also recording this on a MacBook Air, which is not necessarily a beast of a machine, but it gets the job done. There's one other small improvement that I wanted to show you that we could make, and it's not going to make a huge improvement in a relatively small image like this, but it is kind of a general performance enhancement. So if we go back and look at the code, this is just kind of a side tip, is you can see here that we are rendering this image every single time we move a pixel, and honestly whether or not we move the pixel. And that's going to severely decrease the performance of our of this program, because it's having to spend so much time drawing an image. And so one thing that we can do is we can actually move our rendering out to its own function, and this is something that we do a lot in game design, game development, is rather than say re-rendering the screen every single time something in the scene changes, we set it to a fixed frame rate. A lot of times it's 30 or 60 frames a second. So we can create a render function here, and we can move, the rendering of or the drawing of our image into this function, and then very similar to how we had this set timeout to recall our bubble sort function, we can just use a set timeout to recall the render function, and if we want to set this to 30 frames a second, we can just do 1,000 divided by 30 because it's milliseconds. And then again, to start off calling this render function, we can just call it from up here. At the same time, we call our bubble sort function. Then if I go back to the browser and refresh the screen, Again, we'll see after a minute that this is actually sorting again. Again, since this is such a small image and the actual sorting is pretty low on the processor intensity, we're not going to see, I don't think, an obvious performance improvement here, but just a quick little tip as you're getting used to working, say, with Canvas, or even just, if you're doing any sort of game development or rendering work, that you probably want to control rendering in its own function rather than doing it every time you update the scene or the image. And that's all I have for today. Thank you so much for watching. I will be uploading the source code for this project to my GitHub account. There will be a link in the description below, so please check that out. Again, thank you so much for watching. If you have any comments or suggestions for future videos, just please leave a comment below. I will read all of them and respond to them. Again, thank you for your support. If you enjoyed the video, please give it a like. And again, subscribe to the channel, and you'll get notified when I upload new videos in the future. Have a great day, and we'll see you next time.